We will practice with some example about the Lewis structure. Let's see this molecule. What is the Lewis structure for, let's say, OCl2? Okay. OCl2. Yeah. First of all, which element will go to the center? How to make the connection? So look here. What do you have? You have one oxygen, two Cl. First of all, you need to put in your mind some few information how you will draw the structure for the molecule. Usually, we need to have a symmetrical molecule. So O, Cl, Cl. So we have symmetrical. But if you will put a Cl in the middle, oxygen, Cl here, oxygen, this is not asymmetrical. This is not symmetrical. But this one, it is a symmetrical molecule. So this is the first thing. Another thing. Usually, the first element will go to the center. One more thing. When you will be familiar with the electronegativity, usually the less electronegativity, negativity will be in the center. One more thing, the more positive will be in the center. But be careful, guys. This is not always. This is most of the time. So you have to keep everything in your mind when you will draw or suggest the structure. Another thing, hydrogen, don't put it in the center. Always a side atom. Not on center. Okay. Let's start working with Lewis structure of some molecule. Let's say OCl2. How it's gonna be. First of all, count the total valence electron. What is the total valence electron for OCl2? Oxygen will be 6 electron plus 2 times 7 for the Cl. Give you the total 20 valence electron. Do the connection. Oxygen, Cl. How many electrons did you use to make the connection? So look here, this is 2 electrons. This is another 2 electrons, so I use 4. So it will be minus 4. So what left? It is 16 valence electron. Okay, so this is what we have right now. We make the connection. Now, make the terminal atom, the atom on the side, achieve the octet rule. Cl need 6 valence electron. This Cl, 6 valence electron. So I use 12 minus 12. What left? 4 valence electron. Now, put these 4 valence electron in the center of the atom as a lone pair, guys, always. So this is what we have. Okay? And here we will have OCl2. You have to add and check each of them. Does it achieve the octet rule? Does it have 8 electrons around it or not? If yes, so this is the Lewis structure. So look for this chlorine. We have 4 here. 2, 4, 6, and one bond 8. So 8 valence electron. Oxygen 2, 4, 6, 8. So it will be 8 valence electron. Cl 2, 4, 6, 8. 8 valence electron. So everyone achieved the octet rule. So this is the lowest structure for OCl2 molecule. Let's practice with another molecule. Let's say we have the ammonium. Ammonium NH4 positive. Nitrogen, 5 valence electron, plus 4 times 1 for the hydrogen, minus 1. Guys, if we have a positive charge, you will subtract. Negative charge, you will add, and according to the number of the charge. So here, 5 plus 4, it will be 9 minus 1, 8 valence electron. Make the connection. Hydrogen never been in a center, always a side atom. So that's what I did. How many bonds did you use to make the connection? I used 4 bonds. Each bond 2 electrons, so it will be minus 8 valence electron. What left? 0. You don't have any left electron to put it in the side atom or the central atom. That's it. Now we need to check if each of them achieve the octet rule or not, except hydrogen will be satisfied with 1 bond. Dewey rule, we call it. Just 2 electrons. Each hydrogen here achieve the Dewey rule. Nitrogen has 4 bonds, so achieve the octet rule. 1, 2, 3, 4 bond times 2, 8 valence electron. So this is the lowest structure. N, H, 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 H. Don't forget, because we have ion, we need to put bracket around the structure and put the positive charge around it. Put the charge outside the bracket. And this is the lowest structure for ammonia. Okay, let's keep going and practice with some other examples. Again, the lowest structure is very important. We will have some question asking about the lowest structure, but also not only with the question asking about lowest structure. Some question they will ask you about the shape of the molecule, polarity. So you have to start with the lowest structure. So lowest structure, which represent the 2-dimensional structure for the molecule in the space, it is very, very important. Okay, let's look here what we have for, let's say NO3, negative. Calculate the total valence electron. Nitrogen, 5 plus 3 times 6 for oxygen, plus 1, because we have 1 negative charge. So look at here what we did. Here it was minus 1, here plus 1. Why? Because here it was positive, here negative charge. 5 plus 18 plus 1, 24 valence electron. Nitrogen in the center, oxygen, oxygen, and oxygen. I use a 3 bond to make the connection between nitrogen and oxygen, so minus 6 valence electron. What left? 18 valence electron. Make each oxygen achieve the octet rule. Have 8 electrons around it. I use 18 electron here, minus 18. What left is 0. Now I don't have any electron to put it in the center because it's 0 electron. Now I need to check each of them, does it achieve the octet rule or not? Each oxygen, yes, 8 valence electron, 8 valence electron, 8 valence electron, so achieve the octet rule. Nitrogen, no. Nitrogen doesn't achieve the octet rule. It just has 6 electrons because it's a 3 bond. What you have to do in this situation, don't leave it like this because we need each of them have 8 electrons around it. So you will take a lone pair from a neighboring atom and make a double bond. And we will have this molecule right now. After you get the lone pair, you have to remove it from the oxygen. Be careful, guys. And this is the molecule. This is the structure. Put the bracket, put the negative charge outside the bracket. And this is the lowest structure for NO3. Now, let's look for CF4. CF4 molecule. Total valence electron. Carbon it is 4. Plus 4 times 7 for each fluorine. 28 plus 4. So it will be 32 valence electron. Put carbon in the center. Fluorine, 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 fluorine. Yeah. I use a 4 bond to make the connection, so it will be minus 8. What left? 24 valence electron. Make each fluorine, each side atom, achieve the octet rule, has 8 electrons around it. So I use 24 minus 24, but left 0. I don't have any electron to put it in the center. Now the last step, I need to check each of them. Does it achieve the octet rule or not? Each fluorine, yes. What about the carbon? Carbon has 1 bond, 2, 3, 4. So it will be 4 times 2. So achieve the 8 valence electron. And this is the lowest structure for CFO. Now, here, I just want to talk about the resonance structure. When you have more than one possibility to form the double bond, look at here, guys. For the previous example in NO3, I make a double bond between this nitrogen and this oxygen. The question is, why I choose this one? Can I choose the other oxygen or this oxygen? We have 3. Yes, we can. Okay, and there is no problem. So you can form, for example, here, and double bond with this oxygen. Or you can form this double bond with this oxygen. So that means it's possible, and we follow the rule, and follow the rule of Lewis structure road. Now, the question is, which one is represent the real one? The answer for this equation, none of them represent the real one. The experimental data show that in our molecule, we don't have a single bond and double bond in the structure. We have a bond that's falling between the single bond and double bond. So here in this situation, you have to draw the 3 possibilities, or maybe sometimes we just have 2 possibilities, and separate between them by double head arrow, and that will give you a hybrid structure, which is an oxygen, oxygen, oxygen. Any possible position for a double bond, you will make it a dash bond. A dash bond. A dash bond. Okay. And don't forget to put lone pair, lone pair, lone pair, lone pair. Okay. -1. This is the net, the hybrid. And this, we call it resonance. The resonance structure. Let's do another example for the resonance structure. Resonance structure usually is represent the delocalization of the electron, not the atom. Be careful. And we will have it when we have one possible position for the double bond. And you have to draw both possibilities or all the possibilities, sometimes 2 possible structure, sometimes 3, sometimes 4. So you have to draw all the possibilities, possible structure, separate between them by double head arrow, and then you will make the hybrid one. The hybrid one, you will put in any position, any possible position of the double bond, dash bond. And that represents the resonance structure. Let's look at here. Let's say, for example, I have let's look for SO3. Let's draw this structure and see if there is a resonance in this structure or not. 6 valence electron for sulfur, 3 times 6 for oxygen, give you 24. Put S in the center, oxygen, 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 -6, so 18. Make each oxygen achieve the octet rule. That's 18, but left 0. I don't have any chance to make it, but here we have these 3 possibilities. The first one, number 1, could form a double bond with this oxygen. Or number 2, with this oxygen. Or number 3, or with this oxygen. That means there's more than one possibility to draw the structure. So what you're going to do, you will draw all the possibilities, then you will draw the hybrid. The hybrid one, you will put any possible position for the double bond at dash bond. And don't forget to draw the double head arrow. So this is the resonance structure for SO3. Now, not always when there is a double bond, there is a resonance structure. Look at here. Guys, only there is a resonance when we have more than one possibility to draw the Lewis structure for the double bond. Be careful, guys. We have delocalization of electron, not atom. So don't move the atom, just move the electron, which is the double bond. Let's see, for example, if we have HCN. So HCN. So 1 valence for hydrogen plus 4 plus 5 for nitrogen, total is 10 valence electrons. Put carbon in the center, nitrogen, hydrogen, make the connection, minus 2. What left is 8 valence electron. Make the nitrogen, achieve the octet, so minus 6 valence electron. What left? 2 valence electron. Put it in the carbon. So here we will have the carbon, sorry. This one, guys. Now we need to put this lump here. And yeah, that's it. Just one lump here, sorry. C and okay, guys. Sorry, I think there is a mistake. I subtract here 2, supposed to be 4. Yeah, that's why I was confusing what's going on. Okay, so let's do it from the beginning here. I will show you what I did mistake here. Be careful, guys. Okay, put hydrogen, carbon, nitrogen. So how many bonds I use? 2. So minus 4. What left? 6 valence electron, right? Oh, we are fine. Okay, now make the nitrogen, achieve the octet rule. Okay, so you use 6 minus 6, so what left is 0. Now nothing to put it in the carbon. How you will deal with the situation? You will make a double bond. H, C, double bond, nitrogen. Now check nitrogen, achieve the octet rule. Carbon has 6 electrons, so we need another bond, which is triple bond right now. H, C, triple bond, nitrogen. Now, this is the lowest structure for HCN because nitrogen has 8 electrons around it. 8 valence electron, carbon 8 valence electron. Here 2 electrons. Do it for hydrogen. Be careful, guys, with the hydrogen. Hydrogen doesn't have any lone pair, just one bond. Okay, now the question is, do we have a resonance here? Is it possible to have, for example, H double bond C, double bond nitrogen like this? No, that's impossible because hydrogen is satisfied with only 2 electrons. So we don't have resonance here. We don't have resonance. As I said, guys, not always when there is a double bond, there is or triple bond, there is a possibility of having a resonance. Just when we have more than one possible structure, there is more than one possible position for the double bond. You will have the lowest structure. Other than you will have the resonance, sorry, in lowest structure. Other than that, no, there is no resonance. I just want to give you some practice problem for when we have more than one central atom. Okay. Let's say we have C2H6. How will do it? Carbon usually make a connection with another carbon in the organic compound. So how you will deal with this structure? So for example, put carbon here. Put 3 hydrogen. Hydrogen always as a side atom couldn't be central. So what are you gonna You what the possible structure? Carbon. Where you will put the hydrogen. Supposed to be here because each carbon can form 4 bonds, tetraequivalent carbon. So this is the connection. Okay, let's count how many valence electrons. So here, 2 times 4 plus 6 times 1. So 14 valence, sorry, 4, oh, 4, 14, 14 valence electron. Okay, I make the connection. How many bonds did we use? 1, 2, 3, 4, 5, 6, 7. Minus 14. What of 0? Nothing left. I leave it like this, and this is the rule structure for C2H6. Okay, now let's say we have C2H4. Okay, 2 times 4 for the carbon plus 4 times 1 for the hydrogen. We will have 8, 12 valence electron. Put carbon, carbon. Always try to make a symmetrical molecule. So what do you think? If you will put something like that, this is not symmetrical. So you have to make it C, carbon, put 2 hydrogen here, 2 hydrogen in this carbon. So right now, this is asymmetrical. This is symmetrical. Symmetrical. This is not symmetrical. Okay. Now I use 1, 2, 3, 4, 5, 10 electron to make the connection. What left there is 2. Where you will put it? I will put it in this carbon, for example. Now we need to check if each of them achieve the octet rule or not. Hydrogen, satisfied with 1 bond, achieve the duet rule. This carbon, 8 valence electron. This carbon, 6 valence electron. So what we're gonna do? We need each of them achieve the octet rule. But here, after you use 2, 0. Nothing left because I used 2 electrons here, but left. What you have it do in this situation, you will make a double bond by taking a lone pair from neighboring carbon. So it will be a structure like this. This is 8 valence electron, this is 8 valence electron, and this is the lowest structure.